Okay, good morning. Thank you, Miguel, for these very nice words. Thank you, Alexia, for the invitation, and thank you for the whole team, for organizing these great events, and thank you all for being here. So, I mean, I gave when I was invited, when was it, Alexia? Some months ago. So I didn't know, what title to give. I gave like a very broad title on the kind of issues I'm working on lately. And basically I decided to try to summarize in half an hour the work I've been doing in the last 3 years within the context of this ERC project that Miguel was alluding to, right? It started in 2020, and 3 years more or less have elapsed. And I tried to give you like an overview of some of the things that we have been doing and some of the things we want to do in the future, right? So the talk will be divided in two halves, some of the highlights of things that we achieved and where we want to go. Let's see if we arrive or not. But so should I point here? Okay, yeah. So let me just begin with an overview of where this ERC project is framed, right? The title, Miguel was saying, was Healthy Lifespan Inequality, Measurement Trends, Determinant, blah. So basically it's within this setting of increasing longevity that we have been observing worldwide since many decades, right? That we were seeing that individuals survive to older and older ages. This is well known, this is well documented. I'm not reinventing the wheel. But then of course, I mean, there are two important dimensions. It's not just about how many more years do we live, but also whether these extra years are lived in good health or in not a good health, right? And these, you have like this well-known compression versus expansion of morbidity debate, whether these extra years are in good health or not. And so this is, I mean, of course this can make a big difference, whether you extend longevity to have more years in good health or not. It might be completely different as regards to when you organize societies. The other dimension we're looking at in this project is not only whether it's years in good health or not, but also about the distribution, right? We know that life expectancy is increasing, but we don't know if this increasing life expectancy is, so to speak, like equally shared among individuals, right? So the other dimension is about inequality, health inequality. Are these, improvements in health shared by everyone? It's just a group of, privileged individuals that survive to many, advanced stages and others left behind? Well, we don't know, right? And for those of you who know about this lifespan inequality literature, this is a very, very nice quote from Alison van Raalte and colleagues. It was a paper published in Science in 2018, and it had like this nice quote. They said that inequality in length of life is the most fundamental of all inequalities. Every other type of inequality is conditional on being alive. I like this sentence very much. It's a pity that Alison couldn't make it. I think Alison sent a message that she's not able to come. I'd like her to see. My idea in this project is to just go back to this sentence and say that inequality in length of healthy life is perhaps the most fundamental of all inequalities, because everything, or many of the interesting inequalities are conditional upon being alive and healthy, right? And in this very silly example, I'm just showing you like two life trajectories where they might have like the same lifespan, so you have no inequality in length of life, right? This individual A and B, they live equally long, but one of them maybe spent half of his life in a wheelchair, right? So, well, there are inequalities in here, right? So basically, the overall idea of the project is to look not only at differences in length of life, but in length of healthy life. So this is like the main topic of the project. So let me just to clarify ideas, right? This is one of the diagrams I used when I was defending this ERC project in Brussels. So I think it's very nice to summarize the kind of ideas I have in mind. So I show you, and I apologize for you that for those of you who saw this diagram before, because I keep on using over and over, but I think it's very useful to organize ideas. So basically we have like these traditional life expectancy indicators that tell you the average number of years you're expected to live. Then you have like an extra dimension of quantity versus quality, right? So you can enlarge these indicators and look at the quality dimension of life to see how many of those expected years of life are going to be in good health or not. So you have like this bunch, a huge family of health expectancy indicators. This is the quantity-quality dimension, if you want. And the other dimension I was alluding to before is the efficiency inequality, right? There's also a bunch of indicators looking at variability in length of life, whether these lengths of lives are equally distributed or not in the population. And my issue was when motivating this project is that there's like a gap here. So naturally, we are missing this in this picture, this little square. And in this little square, naturally, we would be looking at something which I dubbed as healthy lifespan inequality. Perhaps not a very original name, but basically the idea is to try to look at to what extent length of healthy life is equally or unequally distributed in the population, right? So, and the nice thing about these indicators here is that they combine both, this quantity-quality dimension and efficiency inequality combined into one, right? So this is basically the idea. So these healthy lifespan inequality indicators look at variability in healthy lives. They also could be understood as measuring the age at morbidity onset, right? When you start having morbidity, you start counting how many years you spend in less than good health. And it's important to make this distinction because healthy years of life, you could say that they're normatively desirable. Yesterday we had this conversation with Mark, right? That we know that with length of life, more or less we know that we all want to live longer, but we all want to live longer in good health, right? So this is something that I think it's clear that it's pretty universal. But when it comes to unhealthy years of life, perhaps it's not that clear that we want to, continue expanding this number of years. There are many factors, right, influencing whether it's desirable or not to extend these years in less than good health. I mean, I'm not saying that it's good or bad. I'm just saying it's controversial, right, because it might be very costly and so on. Okay, so this is basically the main idea of the project, to try to have insights on this healthy lifespan inequality. And in this talk, I just wanted to summarize, cherry pick, a couple of studies that we did in the past. And I basically classified these different studies in two axes. One of them being the quantity of estimates that we can generate as regards data coverage and country and years and information available. And the other axis is the quality of the models, the quality of the estimates, and so on. And you can see there's a trade-off. So typically, when you have lots of data, lots of countries and years and so on, the quality of the models of the underlying ideas perhaps are not that good. So we are making stronger assumptions. And on the other hand, in these kind of studies, we have much less country coverage and year coverage, but hopefully the models are higher quality and then they can give us better estimates, okay? So I'm going to start just summarizing a couple of studies very quickly, just hinting at the main results of these first more data intensive, that we have the possibility of exploring many countries, many years, many possibilities, but where the assumptions underlying these methods are, well, a bit shaky if you want, but at least they can give us a broad overview of what's going on, right? So let me start with these ones, study 1 and 2. These are my two colleagues at CED, Jeroen and Amand. They helped me from producing. This is the first product of the project, where we're looking at healthy lifespan inequality. So this was an initial test to see how this creature looked like, right? And we started with the context we knew well, Spain. And we tried to break it down by educational attainment, just using cross-sectional data, 2015. Just very quickly. In Spain, we had this privilege that the statistical office linked mortality registers with education. So we have the educational attainment of individuals at time of death. So we have whether they had primary or secondary or tertiary education. And we also use the GALI indicator. Mark was talking yesterday about this GALI indicator. Perhaps you know about it. It's asking individuals whether in the last 6 months, I think, they had some health issues, right? And this was used as our health measure. And it's basically the method that we used, it's kind of a Sullivan method. You might have heard of the Sullivan method, where you have the survival curve here. You have the healthy survival curve that you obtain by applying the prevalence of good health in a given population by age. And you get the survival curve here, the healthy one. And then in the bottom here, we have the age at death distribution, taking first differences of the survival curve here. And here we invented this new curve, which we call the age at morbidity onset distribution or something like that. So that would measure like the ages at which individuals cease to be in good health. And we were interested somehow in assessing the spread of this distribution, whether this age at healthy, healthy life distribution was more or less equally distributed, right? So this is, roughly speaking, the method that we follow to assess the healthy lifespan variability by looking at the spread of this red distribution, just roughly speaking. So many numbers, I'm sorry, but this is mimicking like the structure of this table, right? Remember this table, we have life expectancy, healthy life expectancy, lifespan equality, healthy lifespan equality. So we try to just reproduce these things here. Many things, but I just wanted you to focus on this bottom line here. We have lifespan inequality for women, for men, low, mid, and high educated and the total. And here we're having healthy lifespan equality for the same groups, right? And the basic takeaway messages I'm drawing from here is that when you look at the sizes of lifespan inequality and healthy lifespan inequality, you observe this is, by the way, using the Gini index of inequality applied to these lengths of life. Basically, what you observe is that healthy lifespan inequality tends to look larger in size than lifespan inequality. You have like this, oops. You have like this number higher than this number higher than this one, this, da, 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 da. So it seems as the ages at which individuals cease to be in good health is more spread out than the ages at which individuals die. So this seems to be like the first message that we get from this data. And the other one is that you look at low educated individuals, they have worse outcomes. When I say worse is that, for example, they have lower life expectancy, lower healthy life expectancy, higher lifespan inequality, and higher healthy lifespan inequality than the other groups. And well, typically, it does seem that you want to live longer. You want to live longer in good health, and you want to have like less uncertainty in the age of death. So in the 4 dimensions here, the low educated individuals are scoring worse everywhere. So it's like a how you call it, like a triple, fourth burden of, I don't find the word, but so they're scoring worse everywhere. Okay, so this would be like the summary of the first study. The second one, we tried to apply very much the same ideas, not just in Spain, which wanted to go all over the world, looking at as many countries as possible and for as many years as possible. And to reach as many countries and so many years, we had to make a sacrifice. We had to use a set of data that is controversial, I agree. I mean, it's GPT data, which has been criticized a lot, but I think it's good enough to give you like a broad brush perspective of what's going on at the world level. Don't ask me about what's happening in Spain, don't ask me what's happening in Italy, don't ask me what's happening in a given country, because perhaps the data for that specific country can be a bit shaky. But I think for overall perspective, that should be good enough to know what's going on, right? So basically what we did here was to focus on seven of these macro regions created by GBD and to construct these healthy lifespan inequality indicators, we were relying on the fact that GBD is constructing these levels of healthy, health-adjusted life expectancy for all ages. So this axis here, so this means that we have like the last column of the life table, if you want. Typically the life table, the last column is the EX, like the life expectancies. So we have the same but with health adjusted. So using this information that was given, we can reconstruct what I call this healthy survivorship curve. So going back to this diagram here, it's basically the same idea, just trying to reproduce these 4 set of curves, but now we arrived to this healthy survivor curve on the basis of this information here, of the health-adjusted life expectancy age by age. So we went back in the life table and were able to construct this healthy survival curve, and on the basis of this, we have this healthy lifespan inequality indicator, the distribution, and from that, we look at the variability in this thing, right? So on the basis of this, these are like the overall trends that we found at the global level. I don't know if you see the colors very well. We see that over time from 1990 to 2019, overall there are declines in this healthy lifespan equality indicator in general. So it means that more and more the ages at which individuals cease to be in good health are more and more concentrated. Except for these guys here. These guys here, both for men and for women, it's high-income countries. I don't know if you see that here. So these are the ones with the most compressed age distribution at the beginning, age and morbidity onset distribution, but it doesn't improve nor deteriorate. It's pretty flat all over the period. So we have made no improvements in this regard, assuming that we want to, reduce inequality, and this has not happened in the last 30 years for high-income countries. If we restrict our attention to those ages above 65, like the typical retirement age in many countries, you observe that this healthy lifespan inequality, both for women and for men, is increasing. So these health profiles of those individuals above 65 are more and more heterogeneous. So you can see individuals that very soon become less than good, have less than good health, and others that survive much more years in good health, right? So we have overall these increases in variability. So this is one of the findings of that paper. And here we wanted to compare not just healthy lifespan inequality, but with regard to life expectancy and healthy life expectancy. So basically, I'm calling this efficiency versus equality. So in one axis, we have life expectancy, which is an efficiency indicator, so how efficient we are in making people survive. And in the vertical axis, we have the inequality, how unequal these distributions are. And here, I just want to draw your attention on the high-income countries, which is the red ones that we had. So if you observe these guys here, for life expectancy and lifespan inequality, we have been successful in increasing life expectancy and reducing lifespan inequality, which is good, so to speak. So there's more efficiency and less inequality. But when you look at the healthy counterparts of these indicators, you can observe that it's true that we have been successful in increasing healthy life expectancy, but there are these stalls, there are no further improvements in reducing this amount of inequality in healthy lifespans. So there are no improvements in here, improvements in the other parts of the world. And when you look at ages above 65, well, you can see, at least for the healthy part, you can see there are big increases. So we are observing increases in the number of years individuals are expected to live in good health above 65, but also there's more and more variability in these healthy spans above 65, okay? So, yeah, I think these are the main results I wanted to share with you in this short period of time. And now, well, I just want to talk about the limitations. This is not perfect. Remember, I was talking about these quantity-quality trade-offs. I mean, here I had a lot of fun looking at so many countries, so many years. I mean, you can see these. I mean, I can't remember how many country, years, sex combinations we have. But then, of course, to get these estimates, there's some price to get these numbers. And some of them is that there are strong assumptions. For example, we're using kind of a Sullivan method, but the Sullivan method is making strong requirements for the data. So one of the things that we are requesting for this data is that, or we are assuming that these mortality rates are the same no matter if you're healthy or unhealthy, which is not very realistic, right? But it's there. I mean, we have to assume that. The Sullivan method as well is relying on prevalence data, not on incidence data, which is not ideal again, because remember that I was interested in looking at the age at morbidity onset, but I mean, if I just have prevalence data, I don't know when this really started. So I can get this estimate just playing these mathematical tricks, looking at the survival curve and the healthy survival curve, and then make as if da-da-da-da-da. But it's kind of, I mean, it's still, heavily modeled. It's not that clear that it should work this way. Another of the problems that we are facing in these initial studies is that the health state indicators that we're using are kind of reversible. I mean that we're not truly measuring the morbidity onset in a way, because in those health indicators, we have the GAL indicator, we have the health-adjusted life expectancy, we have some health conditions from which individuals can recover, right? I can break my leg, and then I count as not in good health, but this is not morbidity onset, right? They can recover the good health and so on and so forth. So in this sense, in future work, we have to focus more on these chronic, non-reversible conditions if we really want to start speaking about morbidity onset and no go back, because it makes a big difference, right? So this is a big thing. And also the third point is that we are ignoring the relationship between this length of healthy life and the other side of the coin, which is the length of unhealthy life. I mean, with these methods I showed you before, with these synthetic methods, we can get an intuition of what the length of healthy life might be by looking at this distribution here. But once an individual ceases to be in good health, we have no idea of how many more years is he supposed to be in less than good health. So we are losing track of this kind of information. So this is a big limitation, right? Because we know we can get an estimate of the length of healthy life, but not the unhealthy part. So many challenges ahead. So this is what I want to talk in the second half of the talk, trying to address somehow like these important limitations. And here I'm going to talk very quickly about this study number 3 and study number 4, where hopefully we can overcome these limitations at the price. The price is that we need better data, we need better models, but then we have like lower quantity. I mean, this can be applied for a few countries where you have like high quality data, and well, it's not as extrapolable as to the rest of the world as the other studies, okay? Studies 3 and 4, so something we call this triangular life table. It's a funny name. And this, well, we've been working on these issues with my colleagues, Tim Rife, Chiara Micheletti, Cosmos Trotz, and Serena Vigetzi. Oops, thank to all of you. Let me begin with the idea, right? So basically now the idea, remember when to look at the length of healthy lives and unhealthy lives. So the idea is that we break down this X, this length of life, in two bits, the healthy and the unhealthy part. In a way that length of life is the sum of these two things. And here, excuse me, but I remember about these, high energy physicists that try to split the atom into little pieces, the protons in quarks, antiquarks. So somehow I feel like we're breaking down the unit of analysis in demography, which is age at death, length of life, X, into smaller sub-pieces, right? So somehow we're trying to look at what happened with these basic components. And it's important to distinguish between these healthy and unhealthy parts, because again, the healthy part, everyone wants more, right? It's desirable. More is better. That's clear that we want to survive in good health. But the other one, the U part, the unhealthy part, I'm not saying it's bad, but it's controversial. I mean, if it's at the cost of, high economic cost, high personal cost, and so on. It's good to document, how these things are distributed and how they are related vis-a-vis each other, okay? How are we going to do this? Well, we are based on several models, different versions of these multi-state models where we have healthy states, unhealthy states, and dead states, just to make things simple. And in some models, we are allowing to go back and forth healthy and unhealthy states. And in some others, we're not allowing to go back from unhealthy to healthy. So this is why I have this question mark here. In some cases, depending on the data that we have, we might want to allow this or not. And, well, the new domain, and this is what gives the name of this triangular life table, comes from here. Now, I'm suggesting to expand our traditional domain and go to this two-dimensional domain, where I'm looking at the age at death. How many years did you spend in good health and in less than good health? These two quantities, H and U, and locate these quantities in this triangle. In this triangle, so here we have this diagonal where H and U add up to X. So in this diagonal, we have all individuals that have left X years. But you can have these guys here at the bottom that spend all their life in good health. And here you have these guys that have spent all their life in less than good health, right? And somewhere in between. So our domain now is this triangle. And the idea is that we keep on picking information about all the individuals, and we get a density function. A density function saying, well, where are the individuals located? Are they here, here, here? Do we find someone here? Do we find someone here? This is just collecting all the information about how these quantities are distributed in this new triangle. Being a density function, if you integrate this quantity over the triangle, you should get a 1. This is like the definition of the joint density function. Just weighting this function by H or U, you get like the health adjusted or the unhealthy life expectancies. These are the traditional quantities. And the nice thing is that if you cross here across these different diagonals, these x's, you integrate along these diagonals, so you get the traditional age at death distribution. So you integrate along these, oops, I lost my pointer here. You integrate along this diagonal, you get the number of deaths at age X that come again from all these combinations of healthy and unhealthy years. And out of this quantity, you get like, this is the traditional age-at-death distribution that we're used to, right? We have like this big hump at older ages, right? So the idea is to extend this unidimensional thing to this bidimensional thing and to see what new information we can get out of this, okay? So let me quickly go to, very quickly, a couple of preliminary examples. One of them, with Team Rife, we have been using this health and retirement study in the US. And from there, we can look at transition probabilities using these ADL, activity daily limitations measures, as a measure of good health or less than good health. And we can assess at different ages whether individuals transition from good health or less than good health for every ages. And out of this information, we can see at the time of death how many years individuals have accumulated in good health and in less than good health. So just making the proper calculations, this was Team job. I mean, he's excellent in this. I would be unable to do this. We generated like these beautiful graphs where we filled those triangles. Remember, this is documenting like the ages at death, but you can also know the number of years individuals spend in good health and less than good health. And these red dots are like the averages. That would be like the healthy life expectancy and unhealthy life expectancy. Horizontal axis and vertical one. And you add up the healthy and the unhealthy, you get the traditional life expectancy. But I think much more beautiful than that, than these numbers, it's like the whole triangle, the whole distribution. You can know whether individuals are concentrated here at the bottom or here at the top, or how much they enlarge here. And you can observe these changes over time. So I think this is fascinating. I mean, there are many things that you can explore on the basis of these entire triangles, right? This is the result for women, which in 15 years, you can see like this cloud of points has moved right upward. So we have more and more women living longer, but also in less than good health. And similar results for men, that over time, this cloud of points is shifting, right? It's increasing over time. So we have like this whole distribution that's moving on. Second example, using health registers in Catalonia. So for the first time, we have access to age at diagnosis of chronic diseases. This is the long list of chronic diseases that we're using. And this is a non-reversible state. Whenever an individual is diagnosed one of these conditions, it's assumed to never come back to the healthy state. And on the basis of this longitudinal information from 2005 onwards, we can estimate the values of age and U, the number of healthy years and healthy years at age at death, just by looking at what age you were diagnosed one of those diseases and what age did you die. And out of this information, we can estimate how to fill those triangles. Okay? So this was done with the help of Chiara Micheletti, who's somewhere there. She generated this beautiful graph. This is like an estimate of the transitions from healthy to unhealthy. So for Catalan women and men in 2019, we have those different ages. How many individuals did transition from no disease to being diagnosed one of those lists of 9, 10, 11 diseases I mentioned before. And as you see, of course, the older you are, the more likely is it that you get diagnosed one of these diseases. This is one of the ingredients that we need for our models. And the other one is to fill the famous triangle. In this triangle, this is real data. The previous one, we had like this, mathematical, blah, blah, blah. But here it's like the real data using the information for Catalan women 2019. So here, Chiara was counting how many women in 2019 died, and when they died at a given age, remember that the ages are in these diagonals, how many years did they spend in good health or in less than good health on the basis of being diagnosed one of those chronic diseases that we had in the list. Okay, so that we see that luckily, Catalan women do not die very young. This part of the triangle, it's pretty empty. So typically people survive to older ages. And lots of these deaths are concentrated at these very high ages and typically spending many of those years of life in good health, right? These guys here spend many years of their long lives in very bad health. Okay, so this is, again, I'm very excited about this possibility because it allows you to go beyond the traditional mortality analysis and introduce like this morbidity part, right? And now the trick, and we're working with with Chiara on this topic is to use like these ingredients to create what we call this triangular life table. So these are like the death counts, and we have the death rates, and we have to transform these into probabilities and create, you know, the corresponding life table. And we have a funny life table where rather than the traditional columns, we have these triangles. We have triangles, 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 and this is why we call this triangular life table, okay? So let me finish just with the last slide. I argue that these healthy lifespan inequality indicators are like an exciting avenue of research because they are somehow able to combine this information on mortality and morbidity in a coherent framework. Like this triangular thing is able to combine both things together. My experience is that typically when you look at mortality studies, they go on the one hand. You look at health studies, they go on the other hand, but it's not that common to be able to put together the two pieces together, like the healthy and the mortality pieces. And when we have like this high quality data, we're able to link those things. And this is why I'm calling about this integration into coherent whole, and this is why I have this name for towards integration in the title of the talk. So just some takeaway messages on these preliminary results of this healthy lifespan inequality. So we found that healthy lifespan inequality higher than lifespan inequality, meaning that the variability in the ages at which individuals cease to be in good health looks higher than the ages at which individuals die. So it is a new layer of inequality. We found that these healthy lifespan inequality indicators in the few countries, just Spain, I mean, I cannot extrapolate, but I have the feeling that it's going to happen everywhere, right? That healthy lifespan inequality is higher among low educated and low SES individuals. Interestingly, healthy lifespan inequality, typically it's higher among women than among men, which is the reverse finding that you observe when you look at lifespan inequality. In lifespan inequality, typically women have less concentration, more concentration, sorry, they are more concentrated, but with healthy lifespan inequality, it's the other way around, right? The ranking is reversed. And we have observed that this healthy lifespan inequality has stalled, if you want. We have seen no improvements in high-income countries in the last 30 years using like this GBD data, right? Which is like a big picture data, but I think it's very interesting. And one of the conclusions of this international study is that it seems that these inequalities in health seem to be larger than the inequalities in mortality, if you want. So I'm speaking about this shifting, this compositional shift in health inequalities, where mortality ones are losing prominence with respect, not prominence, but I mean they are smaller in size when you compare them with respect to the health inequalities, which I think makes sense. And future work, I just highlighted 3 things here, but there are many more dots that I could add, just for the sake of simplicity. I mean, you want to expand this analysis to not just Catalonia, but also Denmark. This is where Cosmos Trots is going to play like a very important role, trying to expand this to not just Denmark, but hopefully also to other countries that have like this good quality data. Another of the things I'm pretty much interested is exploring like the contribution of these healthy and unhealthy years to lifespan inequality. So to what extent this variability in ages at death is attributable to the healthy component or the unhealthy component, because this has implications at the policy level, right? So if you want to curve this inequality down, what's the main source of inequality in this regard? And I think this is also super useful to revisit again this compression versus expansion of morbidity debate, which was alluded to at the beginning of the talk. I conclude with the same. I mean, this is a very important debate, and I think with these tools, it would be very interesting to get new insights on what we will learn about that, right? And finally, just to say that, yeah, these less than good health typically are variables that are avoidable. So there are lots of policies and room for improvement to try to change those things. And I think I stepped over time, so I can stop here. Yeah.